Hi everybody, it's Mrs. Chavis. I am sorry I'm doing this all by myself, so I don't have anybody behind the camera with me, so bear with me. But today I will be teaching the mountains, earthquakes, and volcanoes lesson for those of you that still have to work on this for your for the work that you owe me for this week. Okay? Before you view this video, if you've already started, stop here and get your anchor chart packet so you can follow along as I'm teaching this, okay? This one is for really for 6A. Actually, wait, 6A and 6B, because you all are the ones that didn't get this lesson yet in full. You got it partially, but I want to go through the whole lesson from the beginning, okay? So get your anchor chart packets and follow along. So first we start with mountain building, okay? You already know about tectonic plates and what that's all about. And we know that mountains are built up because of the collisions and the different things that happen with tectonic plates. Okay? One of the things that the book talks about is how tectonic plates can either bend or they can break. And what happens with that, it determines whether it creates folds at the plate boundary or if it creates a fault. So let me go into that in a little bit more detail, okay? So think of spaghetti as we're talking about this. Now you remember that there are 3 different boundaries where tectonic plates come together. And the collisions between the plates can occur in different ways. So remember convergent boundary, remember in class you always saw me doing this for convergent boundary, because that's when the tectonic plates collide or come together, okay? If we have a divergent boundary, remember you always saw me doing this, pulling my hands apart, because in a divergent boundary, those tectonic plates pull apart from each other. And then for a transform boundary, remember you always saw me doing this in class, moving my hands back and forth horizontally against each other, because that's what occurs at a transform boundary, where tectonic plates will slide or glide past each other, scraping each other up along the way, okay? So when we talk about mountains now, always keep the tectonic plates in mind, because the tectonic plates cause stress on the rocks, where the rocks will change shape or deform. The process is called deformation, okay? So deformation occurs in 2 different ways. So the rocks will change shapes in 2 different ways, where they will either bend or they will break, okay? When they bend, and what I want you to think about when we talk about this, think about cooked spaghetti versus raw or uncooked spaghetti, okay? When rocks bend or tectonic plates bend, that is when the rock is placed under high temperature and pressure. So that would be like when we cook spaghetti, okay? Because the spaghetti is being placed under high temperature and pressure from the boiling water, okay? It occurs over long periods of time, although, you know, spaghetti doesn't take a long period of time to cook because it's spaghetti. But when we're talking about huge tectonic plates, that occurs over long periods of time, okay? And what happens is that when certain rocks are placed under high temperature and pressure, they will actually bend, because remember, they start to get they start to become molten. Okay, remember that term molten rock when we talked about mantle convection. Okay, so when rocks are under high temperature and pressure, they start to become a little molten, and then they can bend. Just like when we cook spaghetti, the spaghetti becomes softer, and then, it becomes very noodle-like. Okay, same thing. But when that happens, what happens there is that these plates, the tectonic plates that are placed under this high temperature and pressure, they form bends, and the bends form folds, okay? So the plates will bend, and the bends form folds, okay? But then when we have rocks that are under low temperature and great stress, so they're still under pressure and stress, but when it occurs at a low temperature, that would be very similar to uncooked spaghetti, because you're not adding any heat to it. It's going to stay raw, so it's uncooked, okay? But when rocks are under low temperature and they still have that stress placed on them, the rock becomes more brittle. So brittle like uncooked spaghetti. And then when the stress is applied, and it's applied quickly, what happens is that's when we get a break. So if you were to take raw spaghetti like this and add pressure or stress onto it, it wouldn't bend like cooked spaghetti. It would snap and break. So the same thing happens with rocks. When rocks are under low temperature and stress, they become more brittle. That stress is applied quickly, and it breaks, and those breaks form faults, okay? So when we talk about how mountains start to build up, the bend occurs under high temperature, and then the bend forms folds. The breaks occur under low temperature, and the breaks form faults, okay? Now, there are two different types of folds that can occur due to the bending, because of the bending, okay? And these folds are called synclines or anticlines. Those are the folds that occur. The folds occur because of bending, okay? So when we have synclines or anticlines, that kind of helps form the different types of landforms, or mountains in this case, okay? Synclines arch upward, and I don't know if you can see this clearly. If you can see it in color on your anchor chart packet that I gave you, look, you'll see these words. Sorry, let me find my glasses, like I always have to do in class. Oh, sorry. All right, so here, this is an anticline. This says anticline here. This is a syncline, okay? Anticline, syncline. Now let me explain the difference, because the way the book explained it, it doesn't quite follow the drawing that they included, okay? So let me explain. So synclines, it says synclines arch upward. And in the syncline, the youngest layer of rock is at the core of the fold, the core or the center of the fold. And then the oldest layer of rock is on the outside of the fold, okay? So this would be a syncline. Now, although it's dipping, and that's what they're showing here, that's where the word is. Remember, they're saying it arches upward. So it sits low and it comes up. So they're not talking about this low part of the syncline. They're talking about the way it arches upward from a low position, okay? So it starts here at a low position, but then it arches upward, okay? So it sits low, arches upward, okay? And then the youngest layer of rock is at the center of that fold, and then the oldest layer is on the outside of the fold, okay? And then there's anticlines. Anticlines, they show anticlines up here, which if you look at the, because this would be the inside of the earth, okay? This would be the surface of the earth, where we are. Remember, we're on the surface. Everything else is on the inside, okay? So on the surface of the earth, if you look at an anticline, that's what we would actually see up here. But remember, the anticline arches downward. So although we see a higher elevation of rock, it starts high, but it arches downward. So the syncline starts low, arches upward. The anticline starts high and arches downward. Okay? So that's why this is an anticline. So they're talking about it goes from high elevation and arches downward. Okay? And that's exactly what it says. It arches downward. It's high in the middle. Okay? And then the oldest layer of rock for an anticline, it's the opposite of syncline. So in an anticline, the oldest layer of rock is at the core of the fold, and then the youngest layer of rock is on the outside. Okay? All right, next page. So now we're going to talk, so those were the two types of folds. So now we're going to talk about the three types of faults that occur. Okay? Now, with the faults, let me move this down a little bit. With the three types of faults, keep in mind the three boundaries that we've talked about with plate tectonics. We talked about the convergent, the divergent, and the transform. Okay? So, keep those in mind as we talk about the three different types of faults, because that's important. Okay? So, and the fault kind of tells you a little bit more about what boundary this occurs at. Okay? So, strike slip fault. Sounds, the word slip tells you right away that's a transform boundary, okay? So you should know that right away. So it says at a strike slip fault, remember the fault is actually the crack, okay, between the plates. If we didn't talk about that in tectonic plates, let me just remind you now, the fault is the actual crack in the surface of the earth where two tectonic plates sit next to each other. So the movement at that fault is what we're going to describe here. Okay, and remember, faults are caused from breaking. So if rock breaks and there's that crack between that's a fault. That's the break between the two tectonic plates. Okay, so at one boundary between these two plates, we can have a strike slip fault, okay? And that's the horizontal movement of the rocks. These rocks are under what's called shear stress, okay? And that stress that pushes the rocks in parallel but opposite directions. So it's a transform boundary. All right, what did it say? Horizontal movement, and the movement is in opposite but parallel directions. It's caused by shear stress, okay? And it says as rocks are deformed deep in the crust, the energy builds up, and the release of this energy can cause earthquakes, and it also causes mountains, because remember, this is mountain building, okay? And rocks slide past each other, and it's common along transform boundaries. Okay? Then we have normal faults. These are called normal because of the way that they move, the way that the rocks move against each other. Okay? And so here, this line in between the two plates, so these are two different tectonic plates. So the line between the plates, that's the fault or the plate boundary, whichever you want to call it, okay? But here, since we're talking about the difference between bends and breaks and folds and faults, this is the fault boundary, okay? So this part is called the foot wall. This part is called the hanging wall. And if you see these two arrows, they're moving apart from each other. So you remember from tectonic plates, when rocks move apart, or remember my hands always doing this, when they move apart from each other, that's what type of boundary? I'll give you a second. And I hope you just said divergent, okay? So let's look at this. So what happens here is that there is a downward moving of the hanging wall. So this is the foot wall, this is the hanging wall. The hanging wall moves down because of gravity, okay? This is what we would normally expect if we have one fault that is under a little bit more stress or tension than if we have one rock, that is under a bit more stress or tension than the other, then we would expect them to shift one way or the other. And this normal fault, the hanging wall shifts downward. Sorry, I'm trying to do this. The camera's facing me, so I'm trying to figure out how this is going to look to you as opposed to how it looks to me as I'm viewing myself. So this is the foot wall, this is the hanging wall. The hanging wall is the one that moves downward, okay? So, and that's what would normally occur. That's what we normally expect to happen, where there is movement that occurs due to gravity. That's why it's called a normal fault, okay? And these faults form when rock is under tension, okay? Now, that's different from shear stress. So each of these faults have a different name for the tension or stress or whatever is occurring to the rocks. So when it's at a transform boundary, it's called shear stress. When it's at a normal fault, which is at a divergent boundary, it's called tension. Tension is that stress that stretches or pulls the rocks apart from each other. Okay, and it says it's common at divergent boundaries. And then we have this one. This one is a reverse fault. So this is a normal fault where we have the foot wall and then the hanging wall, and the hanging wall falls downward a little bit farther down than the foot wall. Then this would be the opposite, which is why they call it a reverse fault, okay? So the reverse fault is the upward movement. So now it's not, this hanging wall is not moving downward like it did here. It's actually moving, it's like it's moving against gravity. So it's moving upward, okay? So it's the upward movement of the hanging wall relative to the foot wall. And these faults occur when rock is under compression. Look at the arrows. See the arrows moving inward, okay? We've talked about that also during tectonic plates, our lesson on that. And this is called compression. That's the stress that squeezes or pushes rock together, compression. So compression, convergent boundary, collision. Remember the C's. And this is how you remember it, okay? Strike, slip, shear, stress, transform boundary, okay? At a normal fault, that's tension, and it's the, what do you call it? The stress that pulls rock apart, tension. Actually, you know what you can think of that, if it helps? Think of a rubber band. When you pull and stretch a rubber band, that creates tension because you're moving it outward, okay? Same thing happens here with the rock. If you're moving it outward, you're creating tension, okay? Compression, and one of the 8th graders, I think it was Jalen actually, who, when we talked about compression, he mentioned something in athletics where athletes wear compression socks, I think, or compression shorts. I don't know, but it's the same theory. Compression, where it squeezes or pushes, in this case, rock together. So when people have health issues, or if athletes have an issue going on where they need compression, they need pressure to be put on their leg or their arm or wherever, and they can put on a compression, I don't know what it's called, compression socks or whatever, same thing, okay? So we know that's convergent, all right? All right, so now let's get into the actual mountains that can be formed from everything that we just talked about. So there are 3 types of mountains that can be formed, okay? And they are folded mountains, volcanic mountains, and fault block mountains. So the folded mountains, if you can guess, occurs from when rock bends and forms folds, right? We just went over that in the other page, okay? So it says it's formed when rock layers are squeezed together and pushed upward. So if there's rock under the earth and it's at let's say a boundary, right? A tectonic plate boundary. So there's rock under the earth, and there is all this pressure and tension and everything that's squeezing that rock together. It can eventually get squeezed and pushed upward onto the surface of the earth. So it goes from underground and it gets pushed upward onto the surface of the earth, and that's what forms folded mountains, okay? So it's formed when rock layers are squeezed together and pushed upward. And obviously, because I just kept doing this, talking about, that's a convergent boundary, okay? Remember the collision, okay? And it says it can form as a result of folding, but sometimes it also forms from faulting. Remember, faults are caused by breaks. Folds are caused by bends, okay? So it's not just, it's mostly caused from folding, but it can also be caused from faulting, okay? And then there's volcanic mountains. Volcanic mountains occur when melted rock erupts onto Earth's surface. You all know this, although we're going to get to volcanoes at the end and go into it in more depth. But you know about volcanoes already. And so we have these volcanic mountains when that melted rock erupts onto Earth's surface. And many of the major ones occur at convergent boundaries. But remember, we talked about it. It was in, I don't have my plate tectonics anchor charts in the other room. But if you have yours, if you remember, we saw at a divergent boundary where it showed the tectonic plates, but then there was magma sitting right underneath that boundary. So here it's saying that it occurs at convergent boundaries. That's the major ones. But it also occurs at divergent boundaries, okay? Because at a convergent boundary, it's getting pushed upward. But at a divergent boundary, those plates pull apart. And if there's magma right there underneath, when the plates pull apart, now the magma can just shoot up, okay? And volcanic mountains, just so you know, because I think someone asked this question in class about whether mountains can occur under the ocean. And the answer is yes, they do. They can form on land or on the ocean floor, okay? And it says that volcanoes on the ocean floor can grow so tall that they rise above the Earth's surface and form, what do you think? They form islands, okay? All right, and then here's the last type, fault block mountains. And these are formed when tension makes the lithosphere, remember our physical layers, not the compositional, remember your Earth's layers. So we had the 3 compositional layers, crust, mantle, core, and then we have the 5 physical layers, lithosphere, asthenosphere, oh my gosh, I drew a blank. Lithosphere, asthenosphere, mesosphere, sorry, I had to think of it in the compositional, the M and the M. So lithosphere, asthenosphere, mesosphere, outer core, inner core. Those are the 5 physical layers, okay? So when we're talking about the fault block mountains, it says it forms when tension makes the lithosphere, remember that's now the upper physical layer, when it breaks into many normal faults, okay? So the lithosphere breaks, and now we have all these normal faults and all these different tectonic plates, okay? And then along these faults, pieces of the lithosphere can drop down, okay? And other pieces are left standing, and those pieces that are still standing, those are what forms the fault block mountains, okay? So it's not that these are necessarily being pushed upward. It's when the breaks occur, okay? And then let's say they're sitting level, but then this one falls. And now this one is left standing. And then this is what creates the fault block mountains, okay? All right, next page. Actually, next lesson. So now we're going on to earthquakes. So in your study packet, you have, I need you to do all 3 lessons, mountain building, earthquakes, and volcanoes, okay? So now we're going to talk about earthquakes. Looks like you can see it. Okay, so what is an earthquake? An earthquake is a ground movement that occurs when blocks of rock suddenly move and release energy. So let me stop there. Because I think we talked about it in tectonic plates. I don't recall how in-depth we went. But remember, all of this occurs, tectonic plate movement, earthquakes, volcanoes, the formation of mountains, rock movement, all of that occurs because of stress and a buildup of energy, and then the need to release that energy. And it's the release of energy that causes rock movement and causes earthquakes and volcanoes, okay? Because remember, tectonic plates can be the size of an entire country, okay? An entire country can sit on one tectonic plate. So imagine, and in our case, so like in some countries are much smaller. So in our case, it could be, let's think of an entire state, okay? can be sitting on one tectonic plate. So imagine one state sitting on a plate, another state sitting on a plate, and then deep underneath the earth, there's all this rock movement going on. So understand that rock is always changing, always. And we don't see it because we're on the very surface. We don't see everything that's going on deep below. So if this is the surface, we don't see what's going on all under here, underneath the surface. But there's a lot going on. There's movement. Remember mantle convection. Remember, convection is where we have the difference in temperature with rock, and then there's also a difference in density. And that's how we get that mantle convection, because the hot rock, remember, as rock heats up and becomes molten, remember the phrase heat rises. So the hot rock moves upward, but when it does, it shifts that cooler rock, and the cooler rock moves downward. So we have mantle convection. And it rises because it's less dense. Cooler rock is more dense, so it sinks. So we have that constant motion of rock. And remember, I told you that also happens with the atmosphere, with air, where we have atmospheric convection that occurs, where hot air rises and cooler air sinks. So it's the same thing with rocks, okay? So when that occurs, when there's melting of rock, when there's movement of rock, there's a huge buildup of energy. That if we're here at the surface, that there's a huge buildup of energy underneath the surface. And remember, I don't know if I described it for every class, but remember, energy is neither created nor destroyed. Energy is transferred. Okay? So, if there's this buildup of energy, that energy has to go somewhere, because it's not just going to go away, because it doesn't get destroyed. It gets transferred. Okay? And how does it get transferred? It gets transferred by a release of the energy, and sometimes that can be in the form of heat. It can be in different forms. But what happens, the important thing is that if we're here on the surface and that energy suddenly gets released, that causes movement or release of if it's magma sitting under here, it gets released, and now we have lava. It can be an earthquake, whatever it is that's going on. It's the sudden release of the energy that causes all these things to happen with rock. Okay, it causes the movement. It causes that slip. What's it called? Well, that's the name of the fault, but that shear stress. It causes that shear stress. It causes the compression. It causes the tension. So all those things that happen at the three different faults that we talked about, the slip. Sorry, let me go back really quickly. The strike slip fault and the normal fault and the reverse fault, that all has to do with energy, okay, and the release of that energy. So keep that in mind as I talk about earthquakes now, okay? So earthquakes are ground movements that occur when blocks of rock suddenly move and release that energy, okay? And the energy is released as what's called seismic waves. And we'll talk about the waves more when we get down to this diagram, okay? But it's those seismic waves, or the release of the energy, and they call it waves. It's the movement of the energy outward, okay, that causes the earth to shake and tremble. And that's what we feel as an earthquake, okay? And so what causes that one of the causes is elastic deformation, okay? Elastic deformation, remember deformation is that word that talks about how rocks change shape, okay? So rocks can be deformed or change shape, and that occurs because of the stress that's put on the rocks, okay? As the stress increases, like I just said, the energy in the rock also increases, okay? So when that happens, that stress or that energy has to go somewhere, okay? And what happens is once it gets released, that rock can then return to its original shape, okay? Think of a rubber band. If we take a rubber band and stretch it as far as we possibly can, let me shift a little bit. So we're stretching it as far as we possibly can, right? And then we let it go. What happens is that we stretch it and then we let it go, and it will go back to its original shape, okay? And it's the same thing that happens with rocks, all right? So we have, these are two plates in this diagram, if you can follow along in your anchor charts. So we have two tectonic plates sitting next to each other, okay? And these are sitting along this fault, all right? And then they're pushed and pulled in different directions and at different speeds. So they're being deformed, okay? So there's two things going on. That's deformation, elastic deformation, okay? But it's also causing a buildup in that energy, all right? So it says, as the stress increases and the energy builds within the rock deforms, but it stays there. So it's changing shape. It's squeezing together or compressing together, or maybe it's starting to shift a little bit and pull a little bit apart, or maybe it's going to start gliding past each other. But what happens is that once that stress becomes too great, so you're pulling apart a rubber band, right? And then you let it go and it suddenly snaps back into place. The same thing happens with rock. So it's the sudden snapback that is called elastic rebound, okay? So we have elastic deformation, which is the change in the shape of the rock, and then elastic rebound is that sudden snap back into its original position. And this is what we then feel it as an earthquake. But this is what's actually happening beneath us, beneath the surface of the earth, that's causing the earthquake, okay? And so the bottom part of the anchor chart shows where the earthquakes actually occur, okay? So this brown part, if you're looking at it in color or whether it's black and white, this part here is underneath the earth, okay? And then this top part, which they show in green, but this top part is the surface of the earth. So what they're showing is what happens deep within the earth that causes the earthquakes, or where they occur, okay? So this is the fault line, right? This is the surface, and here's the fault line where the two tectonic plates are sitting right next to each other, okay? And so that's large blocks of rock that break and move past each other, all right? And then there's this spot right here, deep within the earth. This is called a focus, okay? This focus, and if you're doing the questions on the in the study packet, this was actually one of the questions. So these are the answers right here. So I hope you're paying attention, okay? So This is the focus. The focus is deep within the earth where the first motion occurs when an earthquake occurs, all right? It happens right here at the focus. So when an earthquake occurs, that very first spot where it happens, it's called the focus, okay? Then there's a spot, if the focus is, let me turn so you can see. All right, so let's say my fist is the focus, right? This is the focus, but the focus is beneath the earth. Let's say we're right here at Earth's surface. There is a spot directly above the focus. Directly above the focus, that will be right here on the Earth's surface. That is called the epicenter, okay? So if you were to be able to dig a hole straight from one to the other, the focus is beneath the Earth. The epicenter is right there on the surface of the Earth, okay? The epicenter, and I'm sure you've heard in like news forecasts whenever there's an earthquake, they will tell the difference, they will tell the distance of like a certain city from where it is, how far away it is from the epicenter. Because the epicenter is what's on the surface. That's where we are, okay? So the epicenter is the spot directly above the focus on the Earth's surface. And that is where earthquakes will be felt the most, is at the epicenter. So if the city is, let's say, an earthquake occurs in Los Angeles, and let's say, I don't know California very well, so let's say one neighborhood is right there at the epicenter, and they're going to feel it the most, and then as they get further and further away, you know, several other areas will feel it too, and that's because of the seismic waves, but the epicenter is the area where there will be the greatest amount of damage, okay? And that's where it's going to occur first. And then see these circles on your anchor chart, on the diagram? Those are the seismic waves. So it occurs at the focus, and then the waves, the energy, radiates outward from the focus. And then that's how earthquakes can be felt miles away. But even if it's miles away, it won't be felt as strong as it will be at the epicenter, okay? So the seismic waves are the energy that's released when the rocks along the tectonic plate boundaries break, so they deform, and then they rebound. They snap back, okay? That's the elastic deformation, all right? Okay, so now we're going to talk about the three boundaries where earthquakes occur. And we already know those three boundaries: divergent, convergent, and transform. All right? Same three boundaries that it talks about here. I'm sorry. I need to see myself in my camera to make sure this is clear. So these are the boundaries where earthquakes occur. At divergent boundaries, remember divergent, pulling apart, okay? This is where the normal faults occur. That's when tension pulls the rock apart, causing the crust, Earth's crust, right? That's the first compositional layer. So it causes the crust to stretch, and it makes the rock thinner. And when that happens, it says most of the rock at divergent boundaries is thin, so earthquakes tend to be shallow, okay, at divergent boundaries, because they're not pulling completely apart, although that does happen, so don't think that it doesn't. sometimes it's just a stretch, but sometimes it's a pull completely, where it's pulled completely apart, okay? But earthquakes at divergent boundaries tend to be shallow. At convergent boundaries, that's different. When we have a convergent boundary, remember convergent collision? Remember the C's. Convergent, collision, compression. Okay? So, at a convergent boundary, it's where reverse faults occur because of compression. The compression squeezes the rock together, and then it occurs because when the rock is squeezed together, remember we talked about the hanging wall and the foot wall, and then what is this? The reverse fault. So the reverse fault, the hanging wall gets squeezed, but it gets pushed. One plate gets pushed upward while the other one gets pushed downward. And what happens is, says the earthquake occurs when one plate subducts. Remember that word, subduction? When we talked about the rock cycle, I hope you remember, we talked about two different types of movement of rock, vertical movement of rock. One is called uplift, where rock moves upward. One is called subduction, where rock moves downward, okay? So this earthquake occurs when one plate subducts underneath the other into the mantle, okay? And it says earthquakes at convergent boundaries, where that collision, compression occurs, earthquakes at that boundary can be very strong, okay? And then there are transform boundaries. Transform boundaries, remember that's where they scrape up against each other. Remember the S's in this case, even though the boundary doesn't start with an S. But you can think of the scraping of the rock, which occurs at a strike-slip fault, which occurs because of shear stress, okay? So that occurs at a transform boundary when the rocks are moving opposite directions past each other. But it says most of those boundaries are relatively shallow, okay? And then we have tsunamis. And we all know at this point that a tsunami is an earthquake that occurs under the ocean, okay? And it causes the vertical movement of the sea floor. So not only do volcanoes occur under the ocean, earthquakes occur under the ocean as well. All right, and there's an enormous displacement of the water. Everybody's seen the video, God, unfortunately, of when the tsunami occurred. I don't remember what year it was, but how those huge waves like almost engulf an entire city. And what it says is that the waves can travel across the ocean at speeds of up to 800 kilometers per hour, which equates to 497 miles per hour, okay? And what happens is, as the waves move from the ocean closer to the shoreline, closer to where we are, then the waves actually get bigger. They don't get smaller, they get bigger. They increase in size. And this picture, these two pictures in the anchor chart show this one city in Indonesia, Banda Aceh. Please forgive me, anyone, if you know the correct pronunciation. I don't. I'm sorry for that. But in 2004, here was this city, okay, this big, before the tsunami hit. And then a massive tsunami hit, and not only did it kill half of the human population, almost half, okay, it also destroyed 1/3 of the buildings and the infrastructure of that city. So it goes from this to now this. So this, okay, down to this. And just imagine just imagine if it were Tampa. Half of Tampa would have gotten just swallowed by water. And I had students ask me, well, won't it be okay once the water evaporates or goes away? But what you need to understand with the tsunami and with with massive amounts of water that come on land because of a tsunami, that land is no longer there. It's there, but it's now deep underwater. So, or it may not. It depends on how the earthquake occurs. So if it only occurs under the water, if there's no more further tectonic plate movement or the breaking up of the lithosphere that occurs where the people actually live, because it can break up, and but in this case, I think it's not that the plates actually broke up. I think it was just so much water that it could now, just imagine, the land could still be there, but it could be under 40 feet of water now. So that's not going to evaporate in our lifetime, if ever. And so it's gone. It's not going to come back. Buildings have been destroyed completely, not where anything can be rebuilt. Those buildings are now also underwater. So this is the horrible thing that happens with tsunamis. Okay? So now let's talk about volcanoes. All right? Sorry, make it a little lower. All right. So, a volcano is defined as any place where gas, ash, or melted rock comes out of the ground and can be ejected into the atmosphere. Okay? And there's a name for that gas, ash, or melted rock that gets ejected into the atmosphere. It's called pyroclastic materials. Okay? So, and I think that was on the